Hey guys, welcome back to my garage. In this video I want to go over the Acorn step and direction motion controller that I installed on my Dyna DM2400. My Dyna DM2400 was running on a Mach 3 and it was using the parallel port. What you're going to find is when I got the board, I basically unplugged my DB25 cable from the parallel port on the computer and just plugged it into Acorn. Now, one of the things that I had to do, because I have a DC brush motor on my spindle, is I had to put an SI5 onto my KBIC 125, my KB Electronics DC controller. That SI5 is not terribly expensive. You can get it from galco.com, galco.com. Look up SI-5 and you'll find the signal isolator board. That'll get you going, and I just had to run a pair of wires from the Acorn's spindle analog output. It outputs 0 to 10 volts and tie it onto that SI5, and I got my machine up and running. So I wanted to show you that. I intend to clean it up a little bit. I'm going to get rid of a 5-volt power supply and a spindle relay that I have in there now that was an artifact of the Mach 3 conversion. But I just wanted to give you an overview, and I wanted to let you see the machine run with the Acorn just sitting on the bench with a DB25 connector on it, cable onto it, controlling the Gecko G540 that I had for it before I made that conversion. So it's an Ethernet based controller. It's got a DB25 connector on it for, boards like the Gecko G540. I think it would probably work with most breakout boards that are parallel port based. It has a true encoder input. It has it uses the same software that Centroid's developed over the years for their other motion controllers. Which really opens the doors to have an encoder input to accurate threading on a lathe, constant surface speed on a lathe, and potential rigid tapping on a mill. All that is really required is that you have a tight machine and you don't have any lash. Your spindle encoder is belted with a timing pulley 1-to-1 directly to the spindle itself. And then you can use that encoder input. It'll monitor your speed. Again, this is one of the things that users have had trouble with. You're not using a 1 pulse per second input anymore for spindle encoder. You're using a true spindle encoder. You get a standard differential encoder. So anyway, it's remarkable what they put in such a small package. I think it addresses a lot of the features that the entry-level market was looking for. So anyway, with that, let's get to it, and let me show you what this is all about. Again, the point of this was how simple it was for me to go from Mach 3 and a parallel port PC to the Acorn step and direction motion controller from Centroid CNC. Here you see the Acorn board, and you see a DB25 connector there on the left side. That is directly compatible with the Gecko G540. Let me bring you around here. There's the Gecko G540 on the side of my machine, and then you can see the 3-axis cables going to the stepper motors. And then this little connector here is basically the limit switches into the G540. The point of this being is if you have a G540 and quite possibly any other breakout board using a parallel port, the Acorn's DB25 connector is pin compatible. So you could be up and running pretty quickly, I believe. In this particular instance, this little mill uses a DC brush motor to drive it. So what I had is a KBIC 125 DC brush controller there. Now what I had to add is a KBIC SI5. It's a signal isolator board. It's taking the 0 to 10 volt, the 0 to 10 volt signal from the Acorn board, that's this right here, and it's controlling my spindle motor. Now I had to use the signal isolator, so I had to buy this. You can go to galco.com and you can buy these for under 100 bucks, and they push right on the KBIC 120 and the 125. That is the only thing that's externally connected to my Acorn board besides the DB25 connector. Here you see this is the spindle signal output. Otherwise everything is still connected. Really difficult to see in there. But everything is still connected to my Gecko G540. Now, it just makes sense to go ahead and run the limit switches directly to the Acorn board, and I'll probably rewire this thing a little bit. I've already moved this DC control. It was laying flat here. I've moved it this way, and I'm going to do away with this little 5 volt power supply here. I got to keep the 48 volt stepper power supply. I have to keep this one, but I'm going to do away with this 5 volt one. The only reason the 5 volt one is there primarily now is it was turning on and off the KBIC drive, and that's not needed anymore because the Acorn board has 2 dry contact relay outputs, and they can be programmed for spindle forward. So that's what I'm going to do. But it does work the way it's wired right now. The point of this video is I basically unplugged this from the parallel port of my Mach 3 computer, and then I plugged it directly into Acorn, and then I configured Acorn for the limit switches and the stepper motors. And I just configured Acorn's software in the wizard to address the pins and the signals there. So it was pretty straightforward. Let me fire up the computer and I'll show you how it works. Okay, here, let me show you the wizard. Once you've installed the software on your Windows 10 PC, the wizard will come up. And here's where you do all your configuration. So you have 8 inputs and you have 8 outputs. And my limit switches on this machine happen to be normally open. It's not an industry standard, but the machine came that way, built that way, so I just rolled with it. It's kind of difficult to change the switches out. It's a stepper driven machine, so if it comes up on a hard stop, the steppers are just going to stall. There isn't going to be anything catastrophic happening. The steppers are sized for the machine. They're not too big where they can cause physical damage, and that's an important thing to take note of. You don't want to put gigantic steppers on a small machine like this because you can cause some physical damage to the machine. So anyway, here's the limit switches are here. You got input 1, X, Y, Z, and then if you have a 4th axis, and then the input type, right now they're all set to normally open. Input 5 on my machine, because I'm going directly to the G540, is the E-stop circuit, and it's normally closed. This also has probing, so it has probe detect and probe tripped. You can make a simple probe, conductive probe, where you have a lead, you put an isolated probe in your spindle, and then you run it back to the input, and then the machine ground, and then you can do some probing with it, like say an edge detector, finding the center of a hole. And this is the drive OK input. And these are all pre-assigned. If you look up here, it says custom Gecko G540 Legacy. Legacy meaning the G540 is already pre-wired, so its outputs are going to be pre-mapped. You pick that here, they're already pre-mapped for the Centroid software. And then over here on the output side, we have output 1, spindle reverse off. If you have a lube pump, you can hook it up to a lube pump. Since the G540 uses a charge pump, it outputs the charge pump signal in output 3, and that's mapped to the proper pin on the G540. You got G540 spindle forward, and you got a no fault output, drive reset output, flood, clamp. Now, I mean, I'm not using some of these, so you know they don't really pertain. I just left them alone. And then an axis configuration. Let me see if I can zoom you up a little bit closer to that so you get a better look at that screen. Okay, hopefully you can see that. So axis 1 is where you label it. If axis 1 is X, then you use X. Axis 2 is Y and Z, and then you have linear or rotary. Well, these are all linear axis. Axis 4 could be a rotary table, that sort of thing. And then your steps per revolution. Because the G540 is a micro stepper, it takes the standard 200 pulses, multiplied by 10, and you get the 2,000, so they get 10,000 here. The turns ratio, that's determined by the gearing from your motor to the screw. And then my jog rates are set here. So fast jog, the rapids are set to 50, and the slow jog is set to 20 inches a minute, and then the max rate is set to 50 inches a minute, which is fine for a small machine like this. And then you got accel, decel. You know, it's accelerating your stepper motor. This is something you'll have to play with in tuning. You might want to start out with a slow value. The smaller the number, the faster the acceleration, deceleration. The larger the number, the slower. So you may start out with something slower. I'm going to change this one to 0.5. And then direction reversal. So if you wire up your stepper motors and your axis is moving in the wrong direction, this is where you choose it. It's a yes or no. So my x-axis is fine, my y-axis had to be reversed, and my z-axis is fine. Enable drive delay. This is the time that the software waits for the G540 to come up and give its drive OK input. Homing type, in my case I'm homing to switches. I got the limit switches on this machine. You can do a simple home where you move the machine where you want it to home, and then you can just set, you hit all cycle start and it'll set your home position there. But I have switches, so I'm homing to switches. Here's the homing direction. This is typical. X and Y are usually homing in the negative direction, and Z homes in the positive direction, meaning it goes up. Homing sequence. First thing is Z is going to move first to home, and that's typically what you want. You want it to come up, and then Y, it'll move in the negative direction, and then X will move in the negative direction. My travel limits, the limits on this machine, I got 6 inches on the X, I got 5 inches on the Y, and -4 on the Z, meaning when it's coming down, it can go down 4 inches. And so this is a negative value. Make sure you remember that. Spindle setup. My high speed, I have 3-step pulleys, and I set it to the highest range. So my max speed is 10,000, my minimum speed is 300. It has 3 steps, so I can change this. I haven't gotten around to doing that because I've been doing a lot of testing in the software. But depending on the spindle step that I put the belt on, these can be changed, and then you use the auxiliary buttons on the virtual control panel to change that. I am using a touchscreen monitor, so I set that to yes. And USB jog panel, they are working on a USB type device that will act as a manual pulse generator. And then you have advanced. You know, if you have axis inversion, this usually works if you're working on a router or a plasma table where you have 2 stepper motors on an axis that you have to control. So, and you can pair axis. So if you have 2 stepper motors, you can pair the axis, like X, and in this case axis 4, it will control both stepper motors in the same manner. So this is really good. And then you got the maximum number of steps that can be pulsed per second. And with this hardware and software, it's 200,000. It looks like it can do 400,000. So very flexible. But this is the wizard here. So this is where you set up your hardware. So I wanted to show you the wizard. We're not going to change anything, we're just going to leave it, but there are options here. Gecko G540 Legacy. As if you already got a G540 and it was wired to a PC and you just want to unplug the DB25 and plug it into Acorn, this is what you would do. If you're using a G540 just for its stepper drivers, then you would select the Gecko G540 drive only. If you're using Gecko G201, 214s and others, you can use this check. So what they're basically trying to do here is give you a good starting point, some basics. You can always customize them, but if you check one of these, then it will pre-configure the wizard, and the wizard actually writes to the PLC, the programmable logic controller, in the CNC software. So this is new for CNC 12. Makes it very flexible, makes it easy for the users to configure the software. So anyway, let's get to the software. I'll show you this thing run. Okay, let's go ahead and start up the software. I created an icon here that uses ping to establish that we have communications between the PC and the Acorn board, so I'm going to click on it. You can see this is pinging the PC's Ethernet port, and this is pinging the Acorn Ethernet port. Now the software's starting up. And here what you see is this is the software side. The control side of the software, and this is the virtual control panel over here on this side here. And this is new for CNC 12 and was created for Acorn to make it easy for users to be able to control. Centroid took their virtual jog panel, their physical virtual jog panel, and they replicated it and they made it a virtual control panel. So on this panel you can do just about everything. That's why a touch screen is really nice to have. So what we're going to do first is we're going to go ahead, it says press cycle start to send the machine to the home position, so we're going to do that now. You can hear the machine actually going to home. Alright, and so let me take you into the diagnostics section of the software, which is really helpful for checking your inputs. And here it is. If you look over here, it says inputs here, and if you look here, the box, the first input 1 is highlighted, and then right down here it tells you what input 1 is. First axis limit, home limit, okay. And then if we scroll over, now you see the boxes around that LED, and it's the second axis limit, home, okay. Third, okay. And this is the fourth axis. 5 is e-stop. It's assigned to e-stop, and it's okay right now. Let me hit the e-stop button, let you see that change. Okay, you can see that it went red. And you look up here in the user dialog box, it says emergency stop detected. So I'm going to clear that. And it's gone green here, and you can see it's been released. Now you have a virtual e-stop button here. We're going to press it. You can see virtual e-stop detected, and you look down here, it says press to clear. So we'll clear it. Let's go ahead and scoot along here. Next one's probe detect. So if you had a probe set up, you could see this LED go on and off. And then you have drive OK, meaning that the G540 in this case is okay. And that's all we have. We only have 8 inputs, so that's the 8 inputs. Now if we go down here to the outputs, G540 spindle reverse off, output, if you had a lube pump, you could turn it on, a charge pump. We're using this as the charge pump signal now, so that's operational because the The G540 is lit. It's green. Here's spindle forward off. No fault output. And then there's a drive reset output. So if you have drives that can be reset in case of a fault, I'm sure this is where this would be. Here's flood coolant if you want flood coolant, and clamp on. This is, I guess this refers to like an ATC if you want to clamp. So we have eight outputs. So this is a pretty handy display to show you what's going on with your software and your hardware inputs, and it's a good place to test. Let me load the homing sequence. So if you look up here, the CNC m.home G-code file is loaded. So I'm going to go over here, I'm going to press cycle start and watch the LEDs. There was Z, there's Y, and there's X. So you got to see the limits trip. All right. So to get out of that, we hit Alt-I and we're back to the main screen. Let's load a sample program. I'm going to go to NC Files. I have a test program in here, and I'm going to look at the graph. It's just some random moves that I created, and I'll go ahead and run it. So I mean, I could do all this from here. You know, I did a load. There it is. You can load your G code from this display. Cancel, and you can graph the code. Shows you the moves. Again, this is just random. I was making random moves on my machine just to test. And you hit escape, you can get out of that. And so anyway, so let's run this. I'll just go ahead and hit cycle start here, and it should run the code. Let me walk you over to the machine. You can see what it's doing. It's just basically a test program that I wrote to run the spindle. You can hear the spindle. You might not be able to see it, but the spindle is running. It's changing speeds. The axes are all moving. Just basically exercising the machine and testing everything out. And again, the beauty of this is, I'll take you back to the Acorn, is we are only connected via this DB25, and the only other prerequisite was this analog signal input to the SI5, the KBIC. But there's the Acorn, and it's running the machine. And the only thing is, again, this is the DB25. This is where I would have plugged it into the parallel port of the computer. And here's the analog signal output to control the KBIC 125 spindle speed. You can see it doing its thing. And I mean, it probably goes without saying, but this is Ethernet-based controller, and it has a true encoder input for the spindle here. And you know what that can potentially allow you to do is, on lathes you get very accurate threading, and you can do constant surface speed depending on the software package you choose. And on a mill it could do rigid tapping. This entry-level controller you know, is capable of doing that. It's pretty remarkable. I mean, and the size is, you know, it's about 6 inches. Oh heck, I got a tape measure here. Let's measure it. Okay, with the DB25 cable, you're looking about 7.5 inches, and you're looking at about, you're going to need 6 inches minimum. So, you know, let's say 8 by 6 is the space that you're going to need to mount that up and be able to get your cables on it. And there you'll see the power supply for the Acorn. It's just a simple 24 volt power supply. It comes with the kit. When you buy the Acorn, you get the 24-volt power supply. You get this power leads here. You'll get a 15-foot Ethernet shielded cable with it. And support is all peer-based. You have to go to Centroid's support website, and you can ask your questions there and other users. I'm going to try and be there to try and help, and Centroid support staff is going to be there as well to monitor things and try and help people along with configuring the software and the board. Wiring the machine is completely up to you, so you need to have some basic electrical or electronic experience. But if you don't and you want to go straight to it, that right there is your answer, that DB25. If you have a G540 and potentially many other breakout boards, though I've not tested them, I'm using the G540 because the machine was pre-configured that way. This little mill was, I had it wired, I had converted it and put the new steppers on it. I made some new mounts for it. They're direct drive. I made these mounts with some design help from a friend of mine, Brian Lamb. And we had converted, it was running on Mach 3, but the Acorn is just, it's an all-in-one solution. It's hardware, motion controller. It comes with the software that Centroid's always used. They're working on improving it, and I think it's going to be a wonderful option for the OEM market, students that are studying CNC control, motion control, and many hobbyists that already have Mach and they want to upgrade to something that's I think a little bit better, and using the industrial grade software that Centroid's developed over the years, and it's proven. And again, that little board has a true spindle encoder input. So if you put a differential encoder on your spindle, you belt it 1-to-1 with a timing pulley, you can have direct, you can let the software control it for threading, constant surface speed on a lathe, and like I mentioned, the potential to even rigid tap on a mill, all on that board. So just wanted to give you an overview. I'm going to start moving this board into the cabinet, and I'm going to let the Acorn itself, I'm going to wire it up so that the limit switches are hardwired to Acorn, and the spindle inhibit is wired directly to Acorn instead of using, I have a small relay here, and that's all this 5-volt power supply is taken care of now, is just voltage of that 5-volt coil relay. That turns on and off the inhibit circuit on the KBIC motion controller. So yeah, I just want to give an overview. I think it's a wonderful product. I think it's going to do quite well, and it's hardware and software from the same manufacturer that's been doing hardware and software for many years. This is just their foray into the step and direction market. So good luck. If you guys have any problems or questions, you can go to Centroid's user forum, or I'll be happy to try and answer some of them, but I prefer that, and Centroid prefers that all questions go to their user forums. That way, not only you get the answers that you're looking for, the ideas that you're looking for, you can hear from other users, and the other users get the benefit of learning from what you're doing and the problems that you encountered. And other users that have already been there, done that, might be able to help you out. So that's why I say it's peer-based support, and that's what Centroid wants to do, is go for peer-based support, and that helps them keep the cost down and affordable to all the hobbyists and entry-level CNC users. All right, well, that's it for now. This is Marty signing off, saying good luck with your project, and I hope that you are as excited about this new product as I am.